Hello students, so today we are going to start with a very interesting chapter of your physical chemistry, that is electrochemistry. Now let us just understand what electrochemistry is, correct? Okay, what it is, let us see. By the term electro, you can understand that there is something related with electricity, right? And with chemistry, well, we are studying chemistry itself. So the combination of something about electricity and the chemistry inside is electrochemistry in layman's language. But we have to understand how and why are we going to study this particular chapter. To begin with, I have written, see, energy undergo transfer as well as transformation of process. Now what does this statement means? We will get into detail after some times, but this is the very basic sentence that you need to remember while we do this entire chapter. Okay, energy, you all understand, right? Everything we do is a form of energy. I am teaching you, I have energy and I am utilizing it, and I am teaching you. Everything in this universe has some energy. Now using that energy, there is some transfer of energy. Okay, this transfer, this particular term, this particular term we will be, okay, you have studied this in your class 11th in your thermodynamics, right? In your, if you remember, okay, if you remember, you have studied it in thermodynamics about the transfer. When a reaction is happening in your reactant side, in your product side, there is something going on, right? So you have studied about thermodynamics in your class 11th. Okay, if you don't remember, we will get into some whenever it is required, we will get into the details of thermodynamics. And as of now, you have to pay in mind to this term transformation process. Here in this chapter, you will be dealing with transformation process, that is, you will be using chemical energy, you will be having electrical energy, you will be understanding how chemical energy converts to electrical energy, how electrical energy converts to chemical energy, of which we will get into details after some time. So this is basically the unit that we need to understand, okay, and this is very interesting. And mind it, if you understand electrochemistry, your NEET, your JEE, you will be getting so many questions from electrochemistry, from Nernst equation, and many, you will be getting many terms here, Faraday's laws, you will be understanding about current, okay, you will be getting many questions from this particular unit. Also, when you study physics, okay, when you study physics or in your higher classes, if you continue with chemistry, okay, you will be doing many practicals related to it. So you need to understand, also you need to have a little knowledge about the chapter named as redox reaction that you had in your class 11th. Okay, second book, first chapter. Understood? Now let us go into our first thing, that is oxidation and reduction. Before we get into the main topics, I just want you guys to recall what you have studied in your redox reaction that I was talking just a few seconds ago. Okay, now we have oxidation and we have reduction. Now most of us get confused, right? Oxidation, reduction is hard to remember sometimes. Okay, so let us just recall it quickly. Okay, what is oxidation? Loss of electron. Loss of electron is oxidation. Okay, for example, you have zinc here. Okay, understood? Zinc is losing 2 electrons. Suppose you have a packet of chocolate, okay, you have dairy milk, you have 10 pieces of dairy milk into it. If you are eating 2 pieces, what do you have? You have 8 pieces, right? And 2 you have eaten it. So you are losing 2 pieces of dairy milk. Similarly, zinc also has electron. Let us not go into the electronic configuration, but you need to remember that zinc is losing 2 electrons. Hence, we are giving here +2 charge. What does +2 means? +2 means in normal days when you have +2, you understand that I am gaining something, right? If I have +2, that means I am gaining something. I might get 2 chocolate or I might get 2 mark extra. But in the language of chemistry, when you are having +2, it means you have lost something. You have lost something. If you have +2, you are having losing 2 electron. If you have +3, you are losing 3 electron. If you are having +4, you are losing 4 electron, and so on. Okay, so zinc is losing 2 electron. It is losing 2 electron. Understood? Zinc is losing 2 electron, and zinc from 0 it is gaining to +2 oxidation state. What is oxidation? Loss of electron is oxidation. Understood? Also, we have another definition that you have studied in your class 10 chapter number 1. Okay, gain of oxygen is oxidation and loss of hydrogen is oxidation. Now, how to remember gain of oxygen is oxidation and loss of oxygen is reduction? It's very confusing, right? Now, you see oxidation, O-X-I. Okay, see the word letter O. O is for oxidation, O is for gain. If you want oxygen, you will obviously want the letter O, right? So what is that? It is gaining oxygen, right? So you have to remember that if you are having oxidation, oxidation stands for O. You have to gain electron. That is in part of, you are not losing anything. It is, you are gaining something. What are you gaining? Oxidation is for O and your oxygen is for O. So you are gaining oxygen. Understood? Okay, so when you have oxidation, it is gain of oxygen, and when you are gaining oxygen, obviously you have to remember that you are losing hydrogen. Understood? So you are losing hydrogen. Oxidation, loss of electron, gain of oxygen, loss of hydrogen. Understood? Any doubt? I hope it is clear. It's just that you have to just quickly you have to remember it every day. If you are trying to recall it every day, it will be very easy. Cakewalk for you. Okay, next, when you are, what is it? Increase in oxidation number. Now see, what is oxidation number and all these things, we will get into these stuffs. But what do you mean by increase in oxidation? Now see, you had 0 here, now you are having +2. Now what is this? You are having an increase in number, though you are losing electron, but in terms of maths, in terms of simple maths, you are understanding that you have +2, which means from 0 you are getting to +2, right? That is increase in number. So what are we doing? Oxidation. So that is increase in oxidation number. Understood? Okay. Now, what will you call the species that is undergoing oxidation? Right? If I am performing a dance, I will be called a dancer. I am teaching you, I will be called as your teacher. Now, if zinc is undergoing something, what will zinc be called? Right? The species which undergoes oxidation is reducing agent. It's just the opposite thing. Okay? The species which will undergo oxidation. Okay, we are having oxidation is happening here, and out of nowhere you will get reducing agent. When reducing agent come, only at that time you will be having your oxidation reaction will be going on. To remember, you have to just remember in a simple terms that whenever you see oxidation, and reducing agent will be taking part in that reaction. That will, what it will do, it will gain oxygen, or it might lose hydrogen, or it might lose electron. Understood? Zinc is changing its state from 0 to +2, which means its oxidation number is increasing, but it is losing electron. By the term it is losing electron, we understand that oxidation is taking place. Understood? Now we have reduction. What do we have? We have reduction. Okay. Now what is reduction? See, oxidation is clear, I hope, right? Oxidation is clear. Now we are getting into reduction. Now what is reduction? Reduction is gain of electron. In oxidation, if you are losing electron, in reduction what will happen? Obviously there will be gain of electron, right? Okay, so you are gaining electron, and when you are gaining electron, there is a decrease in oxidation number. Okay, you have, see, I have taken an example of copper 2+. Now copper 2+ means, when I told you in chemistry, when you see any plus, which means it lacks electron. Okay, now see, copper 2+, copper lacks electron. Now what will copper do? Copper will gain electron. Okay, how it will gain, what it will gain, doesn't matter as of now. You just need to understand that when copper is gaining electron, okay, when copper is gaining electron, from +2 it is getting to 0. Now in mathematical term, +2 to 0, what does that mean? That means that a decrease in number, decrease in any mathematical number, that is decrease in oxidation number. As I told you, when 0 to plus 2, there is increase in oxidation number. Now from plus 2 to 0, what will it be? It will be decrease in oxidation number. Understood? Now in our oxidation, whenever oxidation is taking place, if reducing agent is coming, so whenever reduction is taking place, obviously an oxidizing agent will be coming. Very simple, right? It's just the opposite. You just need to get into the flow, then it will be very easy. Understood? Okay, let me repeat once again. In oxidation, there is loss of electron, while in reduction, there is gain of electron. Understood? In oxidation, there is gain of oxygen. O for oxidation, O for oxygen, gain of oxygen. Okay, in oxidation, if there is gain of electron, if there is gain of oxygen, then in reduction there will be loss of oxygen. It's just the opposite. If you are giving here something, you are taking away from this. If you are giving here something, you are taking away from that. Okay, so there is gain. If here it is gain of oxygen, in reduction there is loss of oxygen. In oxidation, if you have loss of hydrogen, what will happen in reduction? Tell me. In reduction, yes, you are right. In reduction, it will be gain of hydrogen. Simple. Okay. If oxidation number is increasing here, oxidation number will decrease here. In oxidation, if a reducing agent is coming place, in reduction there will be an oxidizing agent that will be coming into place. Understood? I hope it is pretty clear about for this oxidation and reduction portion. Okay. Now say you will be seeing I have taken Na plus Cl, NaCl salt. We all have salt in our kitchen. Okay. So without salt, any food is tasteless, right? So Na plus Cl, we are having Na plus and Cl minus. Now see what is happening here. What is happening here? Na, it's 0. And here it is plus 1, 0 plus 1, chlorine 0 and chlorine minus 1. Now which one is our where oxidation is taking place and where reduction is taking place? This is the question that I am asking you, and I hope you will give the correct answer, because the right answer to this I will tell you in the next class. As of now, this is your small homework from your oxidation and reduction topic. Understood? Okay. Now we have this term, energy undergo transfer as well as transformation process, which I have told you in the starting of this lecture, right? I have said you that, what did I tell you? I told you that transfer you will be learning it where you have learned it already in your class 11 in your thermodynamics. Now if you have paid attention in my previous 2 units also, you would have understood that what will you understand? I have always mentioned that this portion is from your class 9, that chapter, that topic is from your class 11, that chapter, that portion. I have always precisely mentioned that. Now why am I doing this? I am doing this because everything, whatever you are learning here, class 9, 10th, 11th and 12th, it's a complete circle. Okay, you do not need to, if you are finishing 11, that doesn't mean it is the end. That is a continuation that you are learning in class 12. So everything goes in round and round. Okay, now I am telling you it again and again that this is from this chapter or that chapter, because to keep in your mind that you have to always do some revision on the previous chapters that you have learned in your previous classes. Important if you want to grow in your life, if you want a great career. Understood? Okay, so energy undergo transfer. Transfer gives free energy, and how forward reaction is happening, Le-Chatelier's principle, and etc. you have learned in your thermodynamic unit. What is important to us, what matters to us, is this thing called as transformation, right? Now for transformation, I said we will learn something about the chemical and electrical properties. Okay, for transformation we have chemical energy. Okay, chemical energy is getting converted into electrical energy. This is one case. and the other is electrical energy gets converted to chemical energy. Okay, this is a spontaneous reaction and this is non-spontaneous. Now, what is spontaneous? What do you understand by the spontaneous? You know, in your class when you study, teachers might have said you, this girl is very active, that boy is very active. What do you understand when someone calls you an active person? That means you are too quick to do things. Like I am teaching you here, then I am walking front, I am moving this side, I am moving that side. I am very quick in doing these stuffs, right? I am an active person as of now, right? You are an active person as of now because you are paying attention and listening to what I am explaining to you. Now when I say spontaneous here, spontaneous means they are, you know, very active in this case that we do not need to supply anything extra. They will do things on their own. Okay, which kind of things? Obviously from something from they will be converting chemical energy into electrical energy. Okay, not going into the depth as of now. Okay, so this is spontaneous. Spontaneous means khud ba khud. You understand, right? Khud ba khud means they will do on their own. Understood? And non-spontaneous means obviously this guy sleeps whole day. That girl is like always sitting in the bench and what does she do? She eats her tiffin and doesn't pays attention to my classes. You have such classmates, right? You have, right? Your mummy must be saying you, this girl sleep whole day, doesn't studies, only phone and phone and phone, right? You are an active person? Obviously not. I am also not an active person at my home. We all love to sleep, right? Mamas does the work. Okay, so non-spontaneous here means we need to give something to them. Okay, we have to say that when I am sleeping whole day, mummy will come in, wake up, you have to study. She will tell me only, then I will do my work. Similarly, here too, you have to give something. You will give something, then something reaction will happen and you will get your product in the form of your chemical energy. Okay, understood? Spontaneous and non-spontaneous term you have studied in your 11, but I am sure you don't remember what is spontaneous. Some of you might, but many of you might not remember spontaneous and non-spontaneous. Keep in mind, you take this example as your, you take you as a person and your home and in your class. Okay. You will never forget that. Okay, so this is transformation. Now under this electrochemistry unit, you will be learning about this term, how electrical energy is converting to chemical energy, how chemical energy is converting to electrical energy. You will be having two electrode. Okay, you might not know what is electrode. Like you will be having two pen. You will dip under some solution. You will put a wire and you will have bulb lightning up. Okay, now we will all do magic. Okay, understood? So yeah, energy undergoes transfer as well as transformation process. Now I have an interesting story. We all we always think that why did the apple fall? If apple ही नहीं गिरा होता तो कभी पड़ना ही नहीं पड़ता. We all have that, right? So now the apple is for gravity, obviously. Why I am giving that is because there is obviously some story, some crazy scientist, very curious minded, always does some experiment, very silly experiment, and that results into something very crazy, and that becomes so difficult for us to memorize, and we will be like, oh God, how to memorize this and write in exam. So something like that happened here also. Okay, now what happened? Let me just tell you something, a nice story. Okay, so once upon a time there was a scientist, not going into the name of the scientist, not going into that boring stuff, but the interesting scientist name is not boring. Okay. Okay, so what happened in this? There was an experiment that was conducted. Understood? You understand, right? By the term experiment, you do something in a lab and you get some result. You write the readings, like you must have done titration in your 11th, or you will be doing salt analysis and so on. Okay. So there was a there was a scientist who have taken a beaker, and inside that beaker, okay, there were two scientists basically. Remember, two scientists, crazy science enthusiasts. Okay, there were two scientists, and what did they do? They have taken a beaker, okay, and they have poured some solution that was blue in color. Now in your 12th, nobody will ask you that this solution is blue in color, tell me what it might be. But when you go to your college, if you are not able to tell what is the color of, why is the color of this solution blue, or what you have in your beaker, then though you are gone, your teacher will scold you, okay. But here this blue color solution is, you have taken CuSO4. Copper sulfate solution was taken in a beaker. Okay, now copper sulfate solution is blue in color. Okay, now let me make it nicely. Okay, there was a beaker, and inside that beaker they have poured some blue color solution. Understood? Some blue color solution. Now that blue color solution was of CuSO4, copper sulfate solution. Now what did they do? Okay, and they have dipped a rod. They have dipped a rod. Okay, they have dipped a rod. Like I had a glass, and inside that glass I have poured something blue color, and upon that I have placed my pen. Suppose, just imagine, okay, they have taken a beaker. In that beaker they have placed some blue solution, copper sulfate solution, and on the top of that they have placed zinc rod. Okay, now what did they observe? Okay, zinc rod. What did they observe? They observed that the color, okay, color of the solution started fading. The color of the solution started fading. What do you understand by this? Which means that the blue color, okay, the blue color was getting lighter and lighter and lighter. Okay, the color of the solution was fading. There was a decrease. Now if you have placed this rod, you have placed this, the size of the rod is this much. After some time what happened? This rod was, the size of the rod was getting reduced, and it became like this. Initially it was, I am making some imaginary line, okay, so that you can remember that actually the size was this much. Now when the time passed, okay, as time was gradually passing by, the size of the zinc rod became this much. Okay, that is, the color of the solution started fading. This blue color was changing to light blue, and the zinc rod, okay, zinc rod was getting, the size of it was getting reduced. Okay, also the beaker, see, you have not placed any heat, you have not given any heat, you have not done anything in this world. Okay, you have just taken a beaker, you have poured CuSO4, you have placed the zinc rod. Now you see, suddenly it was getting warm. Array, this is magic, right? If you show it to a child, they will be shocked that, array, there is no heat, how can the beaker be warm? But here some magic was happening, that the beaker was getting warm. Okay, it was getting warm. Also there was, it was observed that some reddish PPT. You understand, right? When I say PPT, PPT stands for precipitate. What is precipitate? If you have seen tuna, right? You know tuna, okay? If you have seen it, when you keep in water, after some time, first it will be, in the completely diluted with the solution. After some time, you will see that it's settles down, when you, in the cup or wherever you have kept it, and it will settle down, and you will have a layer of white color. That is your tuna. Okay, that is your precipitate of the thing that you are using. So it was observed that some reddish type of PPT was observed. Okay, so what is happening here? After some time, what was happening? This rod was getting reduced. There was some PPT. Color of the blue color solution was getting fade, and the beaker is getting warm. Now what happened? Understood? I will tell now what happens. Okay. Now what does this mean? Suddenly you are not providing anything, they are automatically, the size is getting reduced, automatically the beaker is getting warm. So obviously there is some kind of reaction that is taking place, right? There is some kind of what? There is some kind of reaction that is, taking place here. Okay. So now when they have studied, okay, now obviously two crazy, intelligent scientists, curious scientists were studying it. Now when they started studying, okay, now when I said you some red PPT was observed. So when they started what? They started studying the red PPT. Okay, now when they started to study the red PPT, what did they understood? They understood that zinc rod, that zinc rod, they were studying the red PPT. Now red PPT, they thought that, what did they thought? They thought that that red PPT, what did they understood? They understood that the red PPT that was getting accumulated, this was ZnSO4, zinc sulfate. They thought that this is zinc sulfate, okay, and predicted a reaction as Zn plus. They thought that you are placing something of zinc, you are placing a zinc rod. They thought that there you have CuSO4 in a solution and placing zinc, so zinc plus CuSO4 they are getting reacted and they are forming Cu2 plus ZnSO4, and they thought that this particular reaction was happening here. Okay, they thought that in your beaker this particular reaction is taking place, and because of which you are getting this red PPT of ZnSO4. Clear? Okay, now just let us get a quick recall. You had a beaker, you have placed CuSO4, you are pouring, you are pouring a red colored zinc rod, you are having zinc rod, and when you have studied it, you understood that a red PPT was of ZnSO4. Now obviously they thought that the zinc rod that you had, they are reacting with CuSO4 solution, and after reacting with Zn plus CuSO4, this reaction is taking place, and ZnSO4 is our PPT that they thought. Okay, now what they have understood, but there is a interesting thing here, that zinc is, what did they understood? The reaction. They thought that ZnSO4 is our red PPT. Okay, red precipitate is, what is this? This was the red precipitate that was forming in our beaker. Okay, but when they have, studied in more detail about ZnSO4, they have understood that ZnSO4 is soluble in water. They have understood that it is soluble in water, it was soluble in water, and its color is not reddish brown. Okay, so they have understood. See, initially they thought that you are giving zinc, you have CuSO4, then simply the thing is that they are reacting and forming ZnSO4, and they thought that if ZnSO4 is forming, then the red PPT is of ZnSO4, and they thought that ZnSO4 has the color reddish brown. Okay, now when they have studied, and obviously you cannot just tell that this is ZnSO4 and everybody will agree. You have to do some more reaction, you have to study it in more detail. Now when they have studied in more detail, they have understood that ZnSO4 is actually soluble in water. If that is soluble in water, then how will they dissolve properly, then how comes they are getting red PPT? So they have understood that red PPT, that red PPT is not of ZnSO4, which means that ZnSO4 is not soluble in water. So if it is soluble in water, if it is soluble in water, then there is no power in this earth that can make the color of ZnSO4 red. So that will be something else. Understood? So they thought that this PPT cannot be of ZnSO4. Okay, then when they studied in more detail, they have come to the conclusion that this reaction was taking place. Zn plus CuSO4 plus Zn plus CuSO4 is giving Cu oxidation state 0, ZnSO4 plus 2. Okay, here we have 0 and here copper is of plus 2. Okay, 0 to zinc is getting converted to Zn2 plus oxidation. Okay, and copper Cu2 plus is getting converted to Cu0 reduction. See, so much of struggle and finally they came to the equation that Zn plus CuSO4. Okay, obviously you had a zinc rod and you have dipped in CuSO4 solution. So when this thing happened, this reaction actually took place, that is Cu plus ZnSO4 okay, ZnSO4. Now that red PPT was not for ZnSO4, it was for copper. Copper was giving the reddish brown PPT. Okay, now when you observe this reaction precisely, you will be able to see that zinc is in oxidation number, zinc's oxidation state is 0, it is getting converted to plus 2. Okay, it is getting converted to plus 2. When 0 to plus 2 happens, what do we say that oxidation is taking place? Just few minutes back I have explained, 0 to plus 2 oxidation is taking place. Okay, and copper plus 2 to 0 reduction is taking place. Okay, so oxidation is taking place here and reduction is taking place here. So this is basically a redox reaction, and this was the very initial stage of electrochemistry where the scientists have came into the conclusion of terms called as anode. They have came into the conclusion of cathode. Anode is where oxidation takes place, that is anode, where reduction takes place, that is cathode. Okay, that is you are dipping that the zinc rod into the solution. Okay, so what will you say? It is the electrode. Okay, you will be having electrode, you will study it. So you are dropping an anode. Okay, you are giving something called as anode. You will understand it in details. So anode cathode terms, the very basic terms of electrochemistry came from this particular reaction where there was a simple beaker, there was simple CuSO4 blue color solution, simple zinc rod dipped, and some crazy reaction was happening, and the bottle, beaker was getting warmed up. They were curious how this is happening, and out of all these things they have summed up that this particular redox reaction is taking place, oxidation reduction is taking place. From here they have given the terms anode, cathode. Anode, where oxidation is taking place, cathode where reduction is taking place. Very basic terms of that zinc rod dipped is itself an electrode, very basic things of electrochemistry, and you can say that this is the birth of electrochemistry that we will be studying in details in our next class. I hope you have understood and got that thing that you need to understand electrochemistry, because electrochemistry is difficult to understand because there are so many mathematical terms, there are so many derivations, so you need to understand theoretically how things are happening. When you understand theoretically, practically it will be cakewalk. Understood? So yeah, this is all for your today's class. And there is a rule in my class, after my class gets over, open your textbook, go through the topics, go through my class, make lesson, whatever I am saying verbally. If you find some important terms, write it down, make a box in your note copy and write it down. Then what will happen? You will go ahead in your career, and that is important. So see you in your next class. Thank you.